Laser Mike here, and welcome to QTS Tech Bytes. Today we're going to be talking about a familiar subject that we started to delve into the last few times, and that's machine tool axis designation on a typical 3-axis machine. And this could be either a vertical machine or a horizontal machine. And right now we're talking about a vertical machine here because the z-axis is going up here in the vertical direction. And normally the c-axis rotates around that z linear axis, which would be designated as the spindle axis. If this is a horizontal machine, and you'd have a y-axis as the vertical, and the z will be coming out this direction, that will be your c-axis rotating around the z. And remember last time we talked about our linear axes, which is designated as our x, y, and z axis respectively, and they are normally located on the latter part of the alphabet. And the rotary axes, which would be A, B, and C, are on the beginning part of the alphabet. So A is to X, as B is to Y, as C is to Z. So normally A rotates around the X axis, B rotates around the Y axis, and C rotates around the Z axis. And so today we're going to be talking about the 21 different air combinations of a machine tool. We're going to be talking about the 21 degrees of freedom. Or different air combinations. And there will be 21 airs here. And so we have our little axis diagram here. We have a z-axis, an x-axis, and a y-axis. So if we have 3 linear axes, we also have 3 linear airs, or airs of accuracy of position. And on these axes, we have 3 airs of pitch, 3 airs of yaw, and 3 airs of roll. Now each one of these are rotational airs. So these rotation airs are also angular airs. And then we have some more airs, and they are straightness airs. So each axis has 2 degrees of straightness per axis. And we have 3 axes, so now we have 6 straightness airs for a 3-axis machine tool. And we put 2 axes together, the X and the Z. Now we have a squareness air, or a squareness operation. And we put the YX together, or the YZ together, we have another squareness. And so we have 3 squareness airs. So we have, altogether, we have 21 different air combinations on a 3-axis machine tool, or 21 degrees of freedom. Now, if we look at this individually, let's say we have the x-axis here. We have our home position, or our origin point, and we're moving in a positive direction here of x. And we want to designate a dimension to go. And it goes to that dimension, it may be plus or minus that a little bit. A few thousandths or a few microns, plus or minus. And that will be a linear error. And then when we move out, if we're pitching on the axis, like a pitch of a boat or a ship, we have a pitch error there. And we can also have a yaw error. It's moving about the axis. It's yawing as a ship or a boat would move. And we could actually have a roll axis or a roll error, where it actually rolls about the axis as a rotational error around the axis. Just like C rotates around Z, it would also rotate around the axis as well. And so we'd have a roll error. And so now, if we have two straightness errors, we have a vertical error of straightness, an X, and we also have a horizontal error of straightness in X. So we can have a positive error of straightness, of vertical, and a negative error of straightness vertically, or a horizontal error of minus or plus in the opposite direction, which would be in the y-axis direction, which would be the error of X in the y direction. So we have two straightness errors. And so we have 6 error combinations on a linear axis. 1, 2, 3, 4, 5, 6. And we put each linear axis together, we now create a square. So we have 3 axes, we put those together, we have 3 squares. So all in all, we have 21 different error combinations of each axis. So this concludes our talk about our 21 degrees of freedom, just a basic overview of the different axis nomenclatures and the error combinations associated with a 3-axis machine. Thank you for watching Tech Bytes. This is Laser Mike. Thanks for watching, and we'll see you next time.